Hello everyone, I'm Jae-hyung Jung from Seoul National University, South Korea. I will present our recent work on Gaussian mixture Midway-merge for object SLAM with post-ambiguity that was published in RAL. Object-based SLAM that is known to enable high-level scene understanding by exploiting semantic objects in a scene suffers from ambiguous pose detection due to the shape symmetry. For instance, if a handle of a mug is occluded, neural networks confused about its rotation along the symmetric axis. In this case, the z-axis shows the large estimation error. But the problem is that when we consider multiple hypotheses for ambiguity, then the number of hypotheses increases exponentially. To tackle this, we adopt the classical Gaussian sum filter that is basically Bayesian filter with Gaussian mixture in its noise distribution. Also, to efficiently bound the increasing hypothesis, we propose a Gaussian merge method on matrix Lie group that is called a Midway-merge method. Then we apply this framework to ambiguity-aware object SLAM. This is an overview of the proposed method. First, we propagate prior distribution according to an inertial sensor or odometry model. Second, we update and obtain the posterior distribution. Here, since we are aware of ambiguity that is modeled as a Gaussian mixture in the likelihood function, the number of hypotheses is doubled. Lastly, we have to bound the hypothesis to implement in a real system. Then a pair of distribution is merged by the Midway-merge method. Let me develop our method from scratch. State space includes pose as well as robot pose. Then a neural network measures relative pose between a camera and an object. Here we assume that the object pose exhibits a Gaussian mixture model due to symmetry. The noise vector n represents our assumption. According to the Bayes rule, we compute the posterior distribution, and the weight W of mth prior and nth likelihood is recursively updated by the model evidence. But if we set a noise distribution as a Gaussian mixture model that possesses two elements, then hypotheses are doubled at each update, leading to an intractable condition. So we have to merge distributions with minimum information loss. But since we are dealing with distributions on Lie group, it is not straightforward how to merge distributions. Here is our idea to merge them. First, given two PDFs on Lie group, we warp each distribution to the common tangent space called a midway point. This is basically a weighted matrix of two mean matrices. The name came from the fact that this matrix should lie somewhere between the two mean matrices. Then we merge the warped two distributions at the same tangent space by preserving the second moment of distribution. Since the merged mean is always zero, as proved in our paper, there is no need for back projection step to matrix Lie group. This is an implementation detail in the YCV video dataset. We merge the largest and the smallest weighted distributions until reaching the maximum number of hypotheses as 12. We use the pre-trained cozy pose with a single view with the following trained objects. We set the noise distribution for all objects as a Gaussian mixture model with the small 4 degrees and the large 8 degrees standard deviation to consider ambiguity due to symmetry. This analysis supports why we set the noise distribution as a Gaussian mixture. The training loss function for the pose detector is basically discrepancy between labeled points and the inferenced points. But by introducing the symmetric transformation matrix that prevents one-to-many mapping, this introduces biased estimates at the price of efficient training. And the rotation error histogram along the symmetric axis of a mug is well fitted by the two Gaussian components with the small and large sigmas. Here is the demo video, where the pose detector suffers from unstable estimates while our proposed filtering shows stable estimates thanks to the prior information and ambiguity modeling. This is quantitative results where our approach successfully mitigates rotation error along the symmetric axis, Also, our Midway-merge method efficiently merges PDFs by sparing the back projection step, which is required for the conventional merge method. This is the conclusion of our paper. Towards ambiguity-aware objects LAM, we model multi-hypotheses based on a Gaussian sum filter, where we propose a Midway-merge method bound the number of hypotheses. In the experiment, we've seen that our approach can reduce rotation error about 50% over 10K images when compared to the pose detector. As a future work, we like to incorporate Bayesian neural network for pose uncertainty to minimize hand-tuned parameters. And thank you very much for your attention.